so open up to 7.5 here. We're going to talk about angles of elevation and angles of depression. So an angle of elevation is going up, like elevated, and depression is an angle going down. But we'll talk about that as we go here. So first of all, you can see this little dude, as he's looking up, that creates an angle. From his horizontal sight line of sight, looking up, okay, that creates an angle. Looking up to the top of something. Okay, so his line of sight originally, up to his line of sight to the top of something else, creates an angle. And since he's going from straight ahead to up, we call that an angle of elevation. Okay? So the angle of elevation is formed by an observer's line of sight and a horizontal line. Okay? So an angle of elevation doesn't have to be just your line of sight. It could be like something on the ground, like something, like a ball is on the ground and the angle of elevation to the top of something else after it's kicked. You know, it was kicked at an angle of elevation of such and such, of 20 degrees or whatever. So anyway, it doesn't always have to be line of sight. But as we read these situations, these all seem to be kind of follow this idea of what is an angle of elevation. So we have a few angle of elevations, then we'll talk angle of depression, which really we just rearranged to make it an angle of elevation. So let's just start with example 1 here. So first of all, Casey sights the top of an 84-foot tall lighthouse. So it's kind of like the figure that's already up there. An angle of elevation of 58 degrees. So if I'm going to draw this, I'm going to draw an angle of elevation of 58 degrees. Casey is 6 feet tall. How far is he standing from the base of the lighthouse? Well, how tall is the 84-foot tall lighthouse? Okay. Now, if we were going to find out maybe the height of the lighthouse, we have 6 feet to deal with here, right? That might come into play because he's 6 feet tall. That might come into play if we were going to find out maybe the height of the lighthouse. And we would find out the height of our right triangle and then add our 6 feet. But since we're just finding this horizontal distance, I'll just label that X for the part that we're trying to find. How far is he standing from the base of the lighthouse? Well, that's the X part. So now we have an angle, and we're trying to find a side. We already have one side. So from the angle, what sides do we have? Annalise, do you want to help us? Oh, sorry. Okay, well, maybe you will now. So from the 58-degree angle, what sides do we have? We have the 84-foot side and X. So what's the relationship of the 84-foot side and X? Opposite and adjacent. So opposite is the 84-foot side, adjacent is the X. So what trig function is that? You have 1 in 3 chances. Maybe a better one when you look up here. Tangent, okay. All right. So if I set it up, tangent, the angle, 58. And now since we're solving, we have the angle, we're solving for a side. We set that up as a fraction. Equals the side opposite, 84, over the adjacent side, which we're trying to find. Now, do you remember how we solve these? Cross multiply, so 84 times 1 is 84. And then we set it equal to the other direction. X times the tangent of 58. Then we have to divide by the tangent of 58 to solve for X. So on my calculator, that's 84 divided by, parenthesis, tangent. It should bring you that parenthesis, 58. Close the 58, close the tangent of 58, equals, what do you get? Let's see what I got here. See if I got what you got. $52.49. Is that what you got? Feet. Right? It's a distance. And we're measuring in feet. All right, so 52.49 feet. After we put that in our calculator, is what we'll get. If you did not get the 52.49, first check to make sure your calculator is in degree mode. And then check how you actually did the multiplication, if you used parentheses or not. Let's see, next here. Example 2, a dog is standing 5 feet from the base of a tree. So there's a tree. Let's go 5 feet, and we'll have our dog. Looking up at a cat that has climbed 16 feet up the tree. So looking up 16 feet up. What's the angle of elevation? So we're going to find this angle from the point the dog is standing on the ground to the cat. Okay, so yesterday we did these where we found the angle. How did we set those up? Which trig function am I using?
Second.
Yeah, I'm going to do second function, or the inverse function of which one? Sine, cosine, or tangent? Tangent, because 16 is the opposite side, 5 is the adjacent side, and so opposite and adjacent means we're using tangent. So if I do the inverse of the fraction, opposite, which is 16, over adjacent, which is 5, that's going to give me my angle. So on my calculator, I type that in. Second function tangent, 16 divided by 5, and I should end up with 72.65 degrees. Don't forget the degrees. Okay, make sure that's what you get. Okay, everybody have that? All right. Angle of depression. Angle of depression just means now we're looking from some horizontal line of sight or horizontal line down to something. So we're starting from being up above down to something else. Like in this picture, you can see the lifeguard looking down to a swimmer. Okay? So from his horizontal line of sight down to some swimmer, this is the angle of depression. Okay? Now, here's what we do. With angle of depression, if we say this horizontal line of sight and say like the ground or the water or whatever, if those were parallel lines, this angle of depression here would be the same as this angle of elevation from down there that's inside the triangle. Okay? Because those would be like alternate interior angles if these two lines were parallel. Okay, so what we're going to do, we're going to use, when they give us an angle of depression, we're going to use the alternate interior angle of elevation because that's inside the triangle. So that's the one we're going to use. So anytime you have, I don't know, you're setting it up and you get some angle, you're like, oh, so angle of depression is such and such, okay? And you always just use the angle of elevation that is alternate interior with that one. All right, so we'll do example 3, and then you'll see what I mean here. A lifeguard is sitting on a platform. Oh, conveniently, the picture is over here. Looking down at the swimmer in the water. Lifeguard, swimmer, looking down. So here's his horizontal line, looking down, okay? If a lifeguard's line of sight is 8 feet above the ground, so that probably would be this height over here, and the angle of depression to the swimmer is 18 degrees. So this angle of depression is 18 degrees, which means this down here, from the swimmer, you'd have an 18-degree angle of elevation. And we're going to use that because that's inside our triangle. How far away is the swimmer from the lifeguard? So that would be what, this horizontal distance there where I'm marking the X. Okay, so we have an angle. We have two sides, one we're looking for. So which trig function are we going to use? From the 18-degree angle down here, and the one that's inside the triangle, from there, this side would be opposite. The X would be adjacent. So which trig function is it? Tangent. So we set it up. Tangent of the angle equals the side opposite over adjacent. And now we cross multiply and solve like we did a couple of questions ago. So 8 times 1 is 8 equals tangent of 18 times x. And we divide by the tangent of 18. So it's 8 divided by the tangent of 18. 8 divided by, parenthesis, tangent 18, close the 18, close the tangent of 18. And we should get, so test your calculator. I'm going to write it over here to the left. 24.62 feet. Make sure you're getting that answer. After I type this in my calculator, okay, I get the 24.62. Okay, any questions on that? Anybody have any problems finding the 24.62? Okay, hopefully we're getting enough practice on that. Using the calculator, finding the angles and finding the sides in the last couple of days. Okay, example 4. While standing on the top of a hill at a ski resort, Lisa spots the ski lodge below. So I'm assuming you're up on the top of a hill, probably something like this. This is probably the ski lodge down here at the bottom. The vertical height of the hill is 1,209 feet. Okay, we'll say that's the hill, so that would be 1,209 feet. The angle of depression is 53 degrees, so that means this angle here is 53 degrees. So we're going to use that same angle down here. We'll use the one that's inside the triangle. What distance must Lisa ski in order to reach the lodge? Well, is she skiing horizontally or skiing downhill? So which side are we finding? The hypotenuse or the one at the bottom? Yeah, the hypotenuse, because she's going to ski down the hill, right, to the lodge. So we're looking for the hypotenuse. All right. So now look at your 53-degree angle inside the triangle, down here at the bottom. What sides do we have? What relationship? 1209 is opposite. The x is hypotenuse, so that is sine. Okay, so let's set that up. Sine of 53 equals the side opposite over the hypotenuse. All right, so it looks like it sets up just like the previous problem. Multiplying 1209 times 1 and x times the sine of 53. Divide by the sine of 53. So 1209 divided by the sine of 53. So 1209 divided by, parenthesis, sine 53, close 53. Oh, I'm losing it. Running off the page. 1209 divided by, parentheses, sine, close 53, close the sine of 53. I'll write my answer over here. Let's see. What do you get? Anybody have that yet? 1,513.83 feet. Okay. All right, so on your assignment, you have those same types of questions. So angle of elevation or angle of depression, just draw the figure, insert the information, and then solve just like we did. You may be finding an angle or you may be finding a side. So this is the last section of your packet. So you might be doing either one of those, okay, depending on what the question is asking you. All right. If you're having trouble setting it up, ask me so I can see where it is that you're, what information you're missing or something along that way. All right. So the rest of the week we'll have some activities that will kind of help us practice this stuff. But for now, that is the 7.5.